Good day and welcome back for the fourth and final installment on line integrals. In the previous video we introduced the concept of a line integral over a vector field along with this physical interpretation of calculating work. And at the end of the video we mentioned relationships between the curve and the vector field and how we can tell when that work would be positive, negative, or zero. And the intuition is essentially that if the vector field helps a particle move along the curve, there will be positive work. If it hinders the motion, there will be negative work. And if it doesn't help or hinder, there will be zero work. And with that reminder, I would like you to pause the video, take maybe 30-45 seconds, and determine whether each one of these line integrals will be positive, negative, or zero. Now that you've paused the video and thought about the problem for a bit, note C1, motion along that curve will be helped by the vector field, which implies that the line integral over C1 would be positive. For C2, you're essentially going in the opposite direction of the vector field. So the value of that line integral is negative. And for C3, you're essentially moving perpendicular to the vector field. So it's not helping the motion, but it also isn't hindering the motion. So that would be a prime example of zero work being done. So it's important to note there is this kind of physical interpretation of calculating work. With that being said, let's finish our discussion with one more example to get some additional practice. And this is the point that if we were in class meeting face-to-face, we'd be ending our second day of discussion on line integrals, and I would once again be turning the floor over to you, asking you to take 5 to 7 minutes and work through this problem and come up with a value. So with that being said, let's pause the video and see if we can evaluate the line integral. And now that you've taken a few minutes, let's go ahead and fill in some details. The first thing we need is a parametric description of this curve, which is a line segment from 1, 1 to 3, 2. In terms of the vector equation of this line, we have the point 1, 1, plus t times the direction. And we simply think, if I'm at 1, 1, how do I move in order to end up at 3, 2? Well, you move 2 in the x direction and 1 in the y direction. And equating corresponding coefficients gives us x is equal to 1 plus 2t and y is equal to 1 plus t. And using this method, our parameter value t, varying from 0 to 1, allows you to start at 1, 1 and finish at 3, 2. So this is the desired parametric description. That gives us r of t being 1 plus 2t comma 1 plus t, so that r prime of t is 2 comma 1. And in order to evaluate the line integral, we take the definite integral over how the parameter value varies, 0 to 1. We evaluate our vector field f at r of t, and we dot it with r prime. And you don't need to include this step. I like to, at least in the beginning, so that we see precisely where each and every part of that integrand is coming from. Now, in order to substitute in, recall we're thinking that x becomes 1 plus 2t, and the y in the vector field f is going to become a 1 plus t. That is, we're taking our parametric description, and each x and y is being substituted in to the vector field representing the force. So in our case, we would have xy, which would be 1 plus 2t times 1 plus t, comma 3y squared. So 3 times 1 plus t squared. And this is dotted with r prime of t, I've created a little more space there, which is 2, 1. So we multiply together the corresponding components and we sum up. So the first component, we would have the 1 plus 2t, 1 plus t, multiplied by 2, plus 3 times 1 plus t, quantity squared. And this turns out to be a fairly reasonable integral for us to evaluate. Note we would need to expand everything out to have powers of t. And once you've expanded this out into powers of t and you evaluate, which I recommend you all do for practice, what you will end up with is 7/3 plus 11, which completes our introduction into line integrals. In our next section, we will continue this discussion by investigating the fundamental theorem of line integrals. So stay tuned and take care.